something to disappear.
So this is our 7th lecture, and from my side this will be the final one, unless you would be requesting some to kind of extend on some elaborate on some topics that we already had here. We could do that, but my intention is not to overwhelm you with my presence. The lectures will continue, but the next lecture, which will be highly related to reuse, so I will start some topics, will be by Jakub, and then there's holiday, and the week after that, on 24th, there will be another lecture by Victor. We'll see the exact topic. We're discussing several possibilities, so I'll let you know. So for now, we know that Jakub will talk about reuse and more specifically software product lines and how they're related to aspect-oriented software development. You might have heard of this approach, software product lines. I'll also mention something about it, but kind of more kind of state-of-the-art things and possibilities, actual possibilities for establishing software product lines. You'll hear this from Jakub. So I'll just open this. So as we talked some time ago, one of the lectures, and actually throughout different lectures, software reuse is one of the key things in software development. Never achieved to a sufficient extent, but always we see this always as our goal, because people are naturally lazy and do not want to reproduce things that already exist, that could be reused. One side, the other side, this enables us to devote our efforts to other things that are otherwise we will not have time for them. So whole development of human society is highly dependent on reusing different things, and you know that there is quite a trouble with software reuse, mainly because of the other goal that we have in software development, or the other evergreen or ever-standing topic in software development, which is, apart from reuse, what do you need when you have some piece of software? What do you need in order to be able to use it? There is some software or some component or whatever.
Documentation.
Documentation. Why?
To understand how it works, how we can interact with it.
To understand. Yes, exactly. To understand how it works. So the other topic, if we would mention kind of two most important things in software development, then one of them certainly would come as reuse. The other one is comprehensibility. To make software comprehensible, to understand it, to be able to understand it, and comprehensibility is like to maybe to develop our skills in understanding software, but also to develop software so that it is understandable. documentation might be one way to go, but is there any problem with this? Is it
It requires more time from the creator, from the software developer to
something-
write it, and more time from the readers to understand, to read it. It's
Okay.
time complex.
Are there any other problems with documentation? So some additional time is required to write it, to read it. Does it correspond to what it describes?
It has to.
It has to, but does it? How do you know? It may be even certified that yes, this documentation is up to date. It describes everything that there is that is implemented in the software system it documents. Okay, we may trust this, but this simply might be not true, because the moment that you allegedly finish your software system, you start changing it. Some tiny detail. Oh yeah, that this could be a bit like this or something like that. And you see how often previously it was not really possible to get new versions so frequently. Now it's like continuous delivery of new versions, even on your mobile phones. It's every few days you get a new version, an update, and so on. So now this is possible, and this is being used to a great extent. So the documentation itself, then it might be really not quite up to date. It might be a problem to maintain this, and otherwise you have to look at something else while you have your software system there, and why is it not sufficiently comprehensible in order to efficiently work with it. So these are the topics that kind of go beyond what aspect orientation is, but aspect orientation can help with this to some extent. Maybe it introduces some problems in comprehensibility to the other side, but before we take a look at how aspect orientation helps directly, let's remain with reuse in general and for a moment, for a few moments. There are things that are kind of common to all applications in a certain domain. So if you develop them, you can easily reuse them. The trouble is mostly with what is variable, what varies across the systems that are otherwise similar. And the idea of a general reuse, that we develop something and simply publish this, and then people will reuse this in different ways, I don't know how, in their applications, whatever they work on. So some components might be components, we call these components, these might be frameworks, whatever. This kind of reuse is quite limited, because the context in which these things are applied are very different. And for effective reuse, it's not just you need just an opportunity to reuse a particular component, whatever this component is in the widest sense of this notion, but how it fits with the other components, how it is to be connected. So you know that even with toys, when you have like those bricks that you put together, whatever kind of them it is, you do not combine different packages. It's not easy. So, but you can build very different things with that one package, and you can. So it's kind of the use is versatile within that system that is established by them. So they have some connectors, how they are put together, and they fit together somehow. They put together in so many combinations. So there is a kind of way that variability was regulated to become regular, to become according to follow some rules, so that these things can be put together. So as long as we pay attention to this, we can achieve a very high level of reusability. And this is the idea behind the approach called software product lines, which favor this regulated variability within a limited domain. So you decide what this domain is. It can be wider, it can be more narrow, of course. And if you say that this is an insurance kind of application, insurance domain, or banking system domain, or education systems domain, or information systems to support education processes or whatever, you define what it is. So you name it, but you define what it is, what does it belong to this domain, and it is defined not only by what you say, but it is defined also by the applications that you put there into this domain in your mind, and finally that you implement them. So you establish this by simply implementing things, and not just by some declaration. So it's a kind of a in the end, it's a family of applications. And family of applications that you have at one moment, but family can grow. This family can grow, so it includes also some future applications, and it can vary. It can be typically it grows and it is being extended in what is captured by this family. But also, you can imagine that some members of the family simply die, as with real natural families. You don't maintain these things, these applications anymore. So, in this sense, you establish what is common, and these are common things that will occur in all applications, or almost, or sometime at one point maybe you will see these will cease to exist, but for the time being these are common things. But the problem is how to manage these variable parts, and what mechanisms, what implementation mechanisms to use to efficiently implement them. You might say that you might decide to use object-oriented programming and to use classes as this mechanism. You might use for some purposes functional programming or whatever. But the question is why? Why do you use certain mechanisms? And what do we mean by object orientation? To use a class? Okay, sometimes variability mechanism can be implemented through inheritance, because you have some common part and then you have variable parts implemented in derived classes. You can use polymorphism. maybe you don't want to use it for some reasons, maybe for performance reasons or whatever. What are the reasons behind this lie in that application domain that you target. So it pays off first to think abstractly about variability and how things are, and then you decide what you really need to achieve this kind of variability. And this is the key of this process of software product lines, and the scheme roughly looks like this. So up there is the process called domain engineering, and sometimes when we talk about software product lines, sometimes this approach is being denoted as domain engineering. Today, the prevailing notion is software product lines, but some years ago, mainly in Europe, domain engineering was the preferred one. Domain engineering can be understood as in a more specific sense as a process where you really create what you need, the pieces that you then put together in a product, to constitute a product. So your final product is a product. So you must, when you develop software, in order to be successful, to achieve some goal, and to provide some useful things to the final end users, there must be a product. They are not happy with that you develop fancy components that can be put together in many ways unless you really put them together and deliver something that really works. So at the end there's product. But to get to this product, you go through this domain engineering where you first abstractly treat your domain. Mainly you address these variability in the domain. Then you decide about implementation mechanisms. You implement what you can implement. Sometimes you can implement everything, sometimes it's overwhelming, and it's a great investment, because here in this process you are getting no money for this. You are not developing things to offer at the market, to sell components and to profit from this. It's your custom organization, like for your just for the development, just for your within your organization. So you need to bring up products in order to pay your people who are working on this. So there are different strategies to approach software product lines. You all have, I think, this course on software architecture, so we'll talk about this more there, but just the basic things. So how this application engineering proceeds is then that you really get the requirements from the client, but these requirements should be kind of quite related to the features that you identified in your domain analysis. And mostly, you're most happy if you can just pick up certain features and configure your product. This will bring up the components that implement these features, and they will be connected based on the mechanism that you implemented, how they're connected. Nevertheless, this is practically, maybe Jakub will show some example where this is kind of fully achievable, but for smaller scale development, you can imagine this, but in a wider context, you will always be facing some further requirements, new requirements that pop up just out of blue, and you need to do some custom design because otherwise your client will not be happy, and then some custom development, and then you have your product, but these things are not integrated in your software product line. So if you want to do this, you need additional effort to bring these things back there, so new requirements can be propagated into this upper pipe of domain engineering. So this is roughly the idea of the process. It can be depicted maybe also in some other way, but roughly this is software, the approach based on software product lines. As I said, you need to make some profit, so it is sometimes not possible to come with a software product line approach up front. So you're developing your products, you are successful, you have several banking systems, and then you start integrating them into software product line. So this is one typical approach. But as I said, this is a wider topic, so I will not bother you with this at this moment. What is interesting to us here, from the perspective of aspect-oriented software development, is that this mapping of the domain in terms of features. Features can be anything you want. You're not limited in this, so whatever is important. One feature can hide so many things. If you do not want to elaborate it remains like that. But some things then are elaborated, and you come eventually to the point that there are some different possibilities how to put things together. So this is a feature diagram of an account in a banking system. Certainly it has some account number, it has this account type, but it might not have an account type. You may imagine a very simple banking system where there is just one type of accounts, so there is no account type. If it has one, it can be checking account or savings account. You can imagine this to be open, but for now we consider these two. So these are alternatives. So these graphs, sometimes these are compared to and/or graphs in mathematics, are called feature diagrams or feature models, because each of these features needs also some description or some additional models if you want to present it properly, and some additional rules how these features relate to each other, because you cannot put everything in a diagram unless you want, if you want to have it readable. Typically, the most important relationships are put in this graphical form. And one more thing here is this minimum balance rule, which is an optional thing. You can have it, or it might be present or not there. So this minimum balance rule and this whole example might remind you of the example that we also studied, and it's this aspect J in action example of account implementation, where we see that this is the basic implementation of the account. And if you recall, we had this minimum balance rule aspect. Just here, I think it pays off to note that here variability is implemented using inheritance. So this is just normal object-oriented programming. But with the minimum balance rule, we go beyond object-oriented programming and implement the whole thing as a kind of plug-in, plug-out thing. So you put this aspect in or out as you wish. You don't have to affect other parts of your code. Otherwise, variable features are often affecting many places all throughout your software system. So to get rid of one variable feature or to change it, you need to touch many pieces of code. You can do this automatically, like if you define the rule that puts the code in these places. Otherwise, you are doomed to do this manually. With aspects, you can pack a variable feature implementation and then turn it on or off as you wish. And you can imagine that like a whole software product line could be maintained in this fashion, or as much as you can. What problems this might bring? Is it always good to have things like this implemented? One thing certainly, and Jakub will talk about this more, performance issues. Well, this is nothing new because even with polymorphism, we are introducing additional indirection, and we are introducing performance issues. But we feel more comfortable with this because we can write more flexible code. The other thing is that how do you know this aspect is applied to your code? You don't see it in your in the code that is being affected. You don't see it, so you lose confidence. You can't see all the things in your code. But how is it with polymorphism? Again, the same thing. You don't know at each point of your code what method body will be called exactly. So you give up some things, some certainty in some how code. You can't see everything at once for the sake of flexibility. And then we might talk about what is this more comprehensible? In some way, yes. Maybe in some ways, no. So what prevails? It depends. Yet another thing is that by having point cuts, as you know, they can be fragile and actually fragile. They are always fragile, and then they can be more or less fragile. They can break on changes to your base code, to the code they affect. So if you change names, they rely on your point cuts will be invalidated. So there are different issues to consider. So it's not that easy, but this looks like a kind of attractive solution because we pack all the things that are related to one feature and actually reuse it. We'll get back to this also in a moment from another perspective. Here we have this account tracking aspect. I don't know whether I show this to you. It's just a kind of off topic. declare parents. So we can use this marking interface and enforce this marking interface on a number of classes like this. So this is also quantifiable. So you can force all the classes in this package to implement this interface. If it does not enforce any method, it's just a marking interface, and then it doesn't mean that you have to do anything with these entities. But later on, when you rely on the or want to manage some things about all identifiable entities, you can do this. So it is related also to use, but I'm presenting this just as a feature of aspect J. Well, we go here to another thing. How to approach variability at the model level. So we talked about features are kind of high level, very abstract model, but and then there is code. But typically, when we develop software, there are levels of modeling in between. And typically, this is some kind of UML or UML-like modeling is involved. For this, we talked about, in terms of aspect orientation, we talked about theme approach. Theme UML actually enables you to back up things that are composable. So why not? Why not reuse these things? And if you pay attention to this, how these things are like, if you develop these things within your organization, you're developing this software product line, then this modeling approach can be quite aligned with this intention. And actually, there is an approach called aspect-oriented model-driven software product line engineering, and there's been work in this direction. I don't know about how these things made their way to industrial applications. Probably not really. Another topic to consider is if you do not directly consider a software product line approach, but you are doing something which is being known as customization of your applications. Might be kind of understood in a way as software product. These customization efforts can be understood as software product lines. There is a family of products, and you're receiving, you're buying some application which has a line of its main development, and constantly you're getting new versions. But as soon as you get a version of that application, you need to customize it to your own needs. So it is delivered in a way that it is intended to be customized, and the vendor assumes this and prepares your application for customization, but the customization changes are on your side. And when you get this next version, what happens? The vendor does not know about your changes, does not care about them. Okay, they care about them up to the point of supporting them, supporting the possibility of making some kind of variation points in your application. So in these terms, I can relate this approach to software product lines to some extent, but the changes are on your side. So you need to reapply changes, and you need, for this you need to extract changes from your former application. So can you imagine this? How is this complicated to get all the pieces? The documentation can help. So if you documented what has been implemented, you can more easily do this. But you might also have forgotten about some things in the documentation, and there will be some error, and you will not know what is the problem. So you need to compare. Well, you can do this automatically to some extent. You can have some versioning systems that will help you extract the changes, but in the end there must be a lot of manual work there involved. And what if you would implement these customization changes as aspects? So you are building your application and you're implementing. You have some basic application. There is some base code or some basic implementation of your application, which probably does not deliver from some vendor, which probably does not involve aspect-oriented programming. It might, but let's assume it does not. It's more probable. And in your organization, you, on top of this, implement changes. Gradually, this will grow. You will have thousands of changes which need to be applied as soon the new version gets. Some of the changes would have to be adapted because your point cuts will break as the base changes, of course. But in the end, you will be having kind of a bunch of features, additional features implemented as changes to the base code. So this is the idea of the approach that we try to develop and develop to some extent here, which is called aspect-oriented change realization. And the approach is not just about it, okay, aspects are fine as change implementations, so just use them. But the idea is how to make a transition from this level that you see here, which is a change. So one example of a change is the administrator should be able to block and unblock an account from the accounts view. And how to go from this level to the implementation in an aspect-oriented manner. On one side, you have this concept of change, and these changes actually, these change requests typically introduce several changes at once. So you can decouple these two things here, for example, that the administrator can block and unblock an account, and the other thing, a user cannot log in if her account is blocked. And then you can more easily treat these two. So these two changes look like something that we can target with aspects, but if we are not experienced enough with aspect-oriented software development or programming, or we do not want to bother with this too much, there might be some help in already pre-implemented generalized changes. One thing is that this specification of a change qualifies each change as a kind of change type. So you can generalize this blocking, unblocking, or ability to log in, or whatever there was, to domain neutral change, and then for these neutral domain neutral changes, you can develop particular techniques or make implementation change types, as we call them here, or code schemes in aspect-oriented development, in aspect-oriented programming that really directly implement these changes. And then what you need is just to adapt these. You arrive at a solution and you just need to adapt it. So you can have a catalog of change types, and if you proceed roughly as sketched here, this is actually what I told you, and just rephrased in a bit different way. You can get to your implementation. So yet another thing is if you involve here graphical modeling in terms of the theme approach. So these changes would be implemented or presented in a graphical form, and this catalog will be also presented like this, which may be required by the project. This can help communicate design decisions or improve reuse, and especially in model-driven settings. So here is an example related to the first change that we identified in this example that I started with. The requirement says user cannot log in if his account is blocked, in simplified terms. So something like that. This we had there. This is a requirement, and in the theme approach, in that theme doc approach, so the analytical part of the theme approach, we work with requirements and themes. And this theme here, one theme here in this requirement is that you need to check whether the user is blocked, and the other thing is the login theme. This is this basic theme view. Then you transition to the cross-cutting view, like this. So you're still modeling your own requirement, you're in your own domain, so you're not generalizing anything. And you see that this check user blocked theme took control over the things and enforces this requirement on the login theme. I think this sounds pretty logical, because user cannot log in if his account is blocked. So you regulate by checking whether user is blocked. You somehow need to enter this login implementation and manipulate it. Once you have this, you could look through the catalog for something similar on this basic level, and similar in the cross-cutting view. And there is one such change called introduce additional constraint on fields. Of course, this configuration is not what you're looking for. You're looking for how close this generalization is to your domain-specific description. So here you have this user cannot log in if his or her account is blocked, while here you have introduce additional constraint on fields. And imagining what you actually need to do, okay, yes, really I do need to introduce some additional constraint on fields in order to implement this. I come to this solution, and this solution says that, okay, you should introduce this kind of aspect, introduce additional constraint of this type, that will cross-cut your validate form, which is, your login form is of this kind. You recognize these things. I'm just imagining this, how my system would be implemented. If it is implemented in some different way, maybe this change wouldn't apply. So looking at this, you see no signs of your application domain. Introduce additional constraint on fields. Nobody is mentioning any kind of what we had here, user accounts or whatever. Not even to mention like that this is a banking system or something like this. This is a kind of generalized form. And once you identify this, you're actually speaking more in terms of the realization domain. So there are fields there implemented, and there's validation form implemented somehow, and such thing. And with this, you can get a direct recommendation how your aspect could look like. So there is an additional scheme in ThemeUML that says that this is your solution. This is the recommendation. For this kind of change, this is the kind of change that you need to perform within your code. Additional parameter check. And this is the link that can be like maintained in your catalog, the trace link. So you will find sorry, not the additional parameter. To perform the additional parameter check, yes, I said it correctly. You need to perform additional parameter check. It traces to your change or introducing additional constraint fields. And then you can even have a model that will help you establish your implementation. What we did before that, we recommended like pieces of code schemes. You need really to put your code there, your own code, but you see how it looks like, how the aspect is roughly organized. You need to develop your own point cut, of course, based on what types you have in your code. But roughly, you know how to get along with the help of that scheme. If you do not want a scheme, or if you want to kind of be more code neutral or programming language neutral, then you can stick to the theme approach and have things organized like this, or presented like this. What you need to implement here is expressed by this cross-cutting theme, which says in terms of the known system of having this decoupling method calls from actual method execution, preceded by this do prefix. You express what you need to do. And then the rest is just a simple matter of implementation. So you can imagine this approach being applied and aspects being applied like this. What the trouble will be with this approach in the end? You have the base code or the base system. Let's assume for simplicity, as I said, that it is aspect free, but you are putting layers and layers of aspects upon that. And you might lose yourself in all these aspects, and there might be even what will happen if you would have a kind of a change to your own change, because you need to change some things.
Maybe we will have trouble debugging.
Yes, troubles with debugging. How can you mitigate this, or how can you reduce or decrease these problems? Maybe at least for your changes, you do not implement a change of a change as an aspect, but you put these things together. So you maintain your own changes, your aspects, and so on. You tend to reduce the number of aspects and how they are organized. There is a trouble when you have lots of aspects, how to organize them, and there are even approaches to this based on layering aspects. I think instantly I forgot the exact name of the approach. One of the such approaches that actually stratifying aspects. That's an approach that has been developed in order to not to lose track of your aspects. Because even in aspect J, when you do this, they reported the researchers that I was presented at the conference that they presented this. When they had a bigger application, they lost track, and they were not. It was not possible for them to resolve the problems with their point cuts. Actually, what they couldn't resolve was recursively applied aspects. You know that we had this example where we have this control flow. Wherever we have this control flow point cut, and it can actually not that it can, it recursively applies to whatever you add, whatever pieces of advice you apply to your code, it recursively applies. So it applies a piece of advice, and then it applies again to it, and you get your Stack Overflow error. So in order to escape this, you say, okay, target everything, all the join points that I need, but not within the aspect. So you use that not within point cut, not within, to do this. But they said there that this is just a simplified thing, and this is highly misleading. The real trouble that you see in kind of bigger applications is that you cannot resolve these things just by applying few here and there this not within point cut. So you need to reorganize your aspects in a way that which one applies first, which one the aspect precedence, then it's important and such things. So it's a kind of improving things, but then you start losing track. Okay, so this is then in the end how you get along with this. So you find this matching mechanism, and you realize what you need. But I won't bother you more with this approach. I will just mention a few more things that I'm not going to elaborate on. One of them is aspect-oriented implementation of use cases. So you know that we analyze this. It's possible to apply aspects. So this is like in extended relationship. More this asymmetric approach applies, and peer use cases there a symmetric aspect-oriented approach applies. You can emulate symmetric aspect orientation even in aspect J, and you can successfully implement use cases using aspect J. And one more thing here to mention is that you know that even Ivar Jakobson restated some things, or like was more successful to explain the extended relationship and the relationship between peer use cases with the arrival of aspect orientation. And even if you do not care about aspect orientation, you should care about use cases. The book that highly improves understanding of use cases is called Aspect-Oriented Software Development with Use Cases. You don't have to bother with aspect-oriented software development, but it pays off to read this book to see how actually use cases are implementable with aspect orientation, and then this will, even if you don't use aspect oriented programming, will kind of develop some sensibility in you towards preserving use cases in code. And preserving use cases in code is not related just to Ivar Jakobson. This can be done to some extent with aspect orientation, but also to the approach called data context interaction, which I'm not going to talk too much about, but let me just mention the basics. So the idea is to preserve a use case, and here is one, place an order, which is implemented in its own world using something called roles. Because in your use case, even if you have a banking account and then you have a transfer, you have source and destination account. These are actually roles that your account plays. And there are some things that are related to this. This is this ordering system. So this is order being placed. There is a selected product there involved. There are placed orders, and you can implement everything within this world that is actually related to this one use case, so that that code is kind of put as much together and independent of the remaining parts of your system. Why would you do this? Because when changes come into play, they are spoken in terms of use cases. Your client speaks to you in use case language. In terms of what you define in your use cases. They will not tell you, oh yes, I need, that method that you implemented yesterday, we need to, I don't know what to need, to add some code to this tool in order to be, I don't know, to calculate more this value in a bit different way. Now you need to find this method. They will just tell you in terms of high level view of the system what needs to be done. So in order to if you have a small system, you will know exactly, it's not a problem, but imagine thousands of or hundreds of thousands of classes, and I don't know how many people, how many new people, how many people left your organization, and who knows who maintains that part of code. How can you find a code that is related to this change request? So it really is good when you have code which is related to a certain use case in one place. This is just this kind of functionality related or user visible functionality, but inside your system is typically established in terms of what the domain is. And no matter how fancy ways of ordering things they might be implemented in your eShop system based on use cases requested by your client, you will always have an order. There will be an order list. There will be products. There will be customer, like a database model. It can be a relational database, need not be exactly a relational database. Certainly you can develop an object-oriented representation of this like this. But they are not manipulating directly with these things, but what you do needs to be stored in this scheme. And then you need to put together this data, which comes from domain analysis. This is the more stable part, to the context, which formed by use cases. And here is the binding mechanism here indicated, like this. So you go to this object directly of order, but this is not what you want to see when you implement your use case. So these are the interfaces probably that you introduce within your class, and that are actually, it might be valid only for this use case. Some can be transferable to other use cases, some not. And in between, so data context, there comes interaction. So it's in the end of the name of this approach, which is actually how your roles interact within use cases. So data context interaction is not an aspect-oriented approach, but it strives to preserve use cases in code. Aspect orientation can help with this as well. So this approach can be implemented more or less in an aspect-oriented manner. This is just a summary, don't bother with this. Then, this is a scheme that I like to present. You might have your software architecture as a string and your use cases as pearls, as independent as they can be. And you can just put your new pearls on this string without interfering with it, without having to break it, without having to untangle it. And so on and so forth. You can get rid, of course, of some of these cases. It's not that clean like this, but if you imagine this when you start developing a software system, you might come close to this method. So this is just to remind you that we did something similar. So this is conditionally skip operations. I would not say this is exactly a use case, but we can imagine, you know, that Alistair Coburn talked about these use cases of different levels, and one level is user goal level. This is this level is our primary interest, but there are those sub functions, deeper functions, and you can even represent as use cases some things that you would not imagine being of interest to the end user. But for the sake of modeling, you can elaborate them as use cases, and conditionally skip operations might fall into this category. And if you imagine this as a use case, well, this is our use case role, operation class, and this is what we do with this role, and this is how we connect our role to the rest of the code. So this comes close to the idea of implementing data context interaction with aspects. So you maintain your own world, or for your own use case defines these roles in terms of interfaces, and then they are bound by aspects to the domain elements. You do what you do, and then you should unbound them, but you can really do this in AspectJ. You can bind roles, but you cannot unbound. Once you've said that alarm implements operation class, you're done with this. Unfortunately, this does not spoil too much, because you can enforce further implements mechanisms as you go. You can just imagine that more dynamic languages could offer you, like Ruby, like Python, could offer you more flexibility in enforcing or in binding and unbinding roles. And some things will be there even in what Jakub will present related to this. So we'll see this next time. And I don't know about Victor. I think he might also come with some things related to these flexible mechanisms that enable you to more dynamically program in an aspect-oriented manner. So I will end this lecture here. So regulating variability within a domain is an effective way of achieving software usability, as we saw. We saw that aspect-oriented feature implementation keeps them pluggable. And we saw how use cases can be preserved in code, and aspect-oriented programming can help achieving this. Questions, notes? No questions, no notes, no remarks, no objections to the lecture. I guess you are tired and you had your seminars and so on. Maybe I kept you for a little bit longer than I really wanted, but I hope that this lecture gave you some insight on the possibilities that aspect orientation brings up. And even if you do not use aspect-oriented approach, you can always kind of follow a bit of philosophy of preserving use cases that can help maintain your code more reusable. Thank you for your attention. See you the next time, which will be actually we are not affected yet by holidays, so really it will be next time, so in a week time, next week. And then a week after that, we have a holiday. Okay.